Hello, class, and welcome to chapter 12. I'm just going to mute my computer so you don't hear that recording thing in the future. There we go. All right, so in chapter 12, we are talking about linear regression and correlation. The basis of linear regression is linear equations. Okay, if it's been a while since you've been in algebra, that's totally okay. In algebra, a lot of times we're taught linear equation is y equals mx plus b, right? Y equals mx plus b. And that is the same linear equation that we are dealing with now, but we are going to name it something slightly different. We're going to say y equals a plus bx. That's just because that's how it is displayed in our textbook, and I want to try to stay as consistent as possible as we look through the textbook to our notes and what we look at in our homework and such. All right, so in this case, this is the y-intercept, and this is the slope. Okay, y-intercept is the one without the x. The slope is the one that's attached to the x. A and b are two constants. They will be values. Here, if you look down here, we have a couple examples. A here is 7, B is 4. X and Y will stay as an X and Y. Those are the two variables that we're going to be questioning. Are they related to each other? Are they not? X will be some kind of variable. Y will be some other kind of variable. In a linear equation, x is called the independent variable, y is called the dependent variable, because when you go to plug something into the equation, we typically plug in for x, and then y is adjusted depending on what that outcome actually is. All right, the graph of a linear equation is a straight line, right? It's a line linear equation. And we're going to go ahead and look at the graph for this equation here. So again, y-intercept and slope. Now your slope is the rate of change, or, rise over run, the change of y over the change of x. Just trying to think of other ways you may have heard it in the past, all right, because this is something that you probably have seen at some point in your life. Another easy way to graph these things is to just make a little t-chart, pick some ordered pairs to go ahead and put on here. So I'm going to pick some x's, I'm going to plug them in and get the corresponding y's. The y-intercept is always where x is 0. This is our x-axis. This is our y-axis. So if I put in 0 for x, my y value is -1 plus 2 times 0. Which is just -1 plus 0, -1. Again, why this is the y-intercept, because we have 0, -1. On the y-axis, at -1 is where we cross. All right, if I plug in a few more points, -1 plus 2 times 1, that's -1 plus 2, that's +1. So we have an ordered pair at 1, 1. All right, I'm going to try to get to some good points as we go through. So I'll plug in 2. We don't have to do an entirely accurate line. My scaling here is not the best. So -1 plus 4 is +3. Again, my dots might not look like an exact line, but these would be an exact line. Let's put in something a little higher. Let's put in 6. And then we can just draw the line from there and call it good. So -1 plus 2 times 6. That's -1 plus 12. That's +11. So as best as I can, I'm looking across here, just above 10. I'm going to put a dot right about there. And again, mine is not going to be perfect. You just take something with a straight line, as straight as possible. Since my dots weren't perfect down here, if I make them a little bigger, they'll look a little more in line. They should be exactly on that line. What this line represents is every single x to y. So there's some 3 should be somewhere around 5. All right, 5 should be somewhere less than 10, maybe. All right, maybe I think it's 9, 5, 9. So you see these points, every single point on this line is actually another ordered pair. It's another combination of numbers. All right, so with these 4 variables that we've discussed again, X is the input value. Y is the output. We put in an X value, we get out a Y value. A is the initial value or the y-intercept. So it's also called the initial value because if we were talking about a distance someone travels versus the time it takes them, at time 0, wherever they started distance-wise is that initial value. That's the y-intercept. So the initial value, or in other words, how much output you begin the situation with, or the y-intercept. And B is the slope, or the amount that you are increasing or decreasing per unit X. So what you see up here is our slope is that, hey, we are for 1 unit X, we increased 2 vertical steps. 1 step to the right from 0 to 1, 2 steps from -1 to 0, 0 to 1 to get to that next place. That's why our slope was a +2. We went 1 step in the X direction, we went 2 steps in the Y direction. Again, this is also called the slope. And that is our introduction just into what a linear equation is. Again, this is going to be happening in the background, and we're going to do some solving with linear equations to just become a little more familiar with them again.